As we continue on with section 6.1, one of the things that we have to look for is how to actually classify something that we only know by the points that are given. So first of all, if you see something like this, the first step that you should have is actually to graph it. So if I start out, 1, 2 would be 1 point. That's my L. And then I have 3, 3. That's my M. 5, 2 right here is going to be N. And then 3, 1 right here is going to be P. So I'm actually going to connect these to make lines on the sides, and I want to try to classify this. Now, I know from just looking at the kind of shape that's made that I have some idea that I want to deal with, maybe a rhombus or maybe a parallelogram or something like that. It doesn't look like there's going to be 90-degree angles here, but the only way I'm going to know that is actually by looking at what the slopes are. And also, I need to know if things are parallel because the slopes will match, or if they're going to be perpendicular because they're negative reciprocals of each other. So those are things we're going to kind of think about. So I've kind of set up a chart here to kind of help you. If I know how long each of the sides are, if I know what the slopes are, those are things that can really help me. Now remember, distance is going to require us to use the distance formula. And it's been a little bit since we've dealt with this. So I'm just going to do a little reminder here of the distance formula. And then remember the slope looks like this. Now I want you to notice that this piece in here actually matches the bottom of the slope. And this part right here matches the top of the slope. So actually if I find the slope first, it may be actually easier to solve this part. So I'm actually going to start out by finding my slopes in all of these. Now I just want you to take a look at how I set up this table, because this is something I would think most people would be pretty successful at using. And all I've done here is if I want to find, how long the side is from L to M, I've actually just listed my points. And actually putting them right above each other is kind of helpful, because when I go to do slopes, it's y's minus x's. So if I do y's, it'd be 3 minus 2. Notice that that is, let me turn my highlighter on. That is just this pair right here. And then I'm going to do this pair here. So remember, the y's are going to go on top, and the x's are going to go on the bottom. So on the bottom, it's going to be 3 minus 1. So this ends up being 1/2. Now anything else that will have a slope of 1/2 is going to be parallel to it. So we're going to keep going. So in this one, on the top, it's going to be 2 minus 3. And then 5 minus 3. So negative 1 over 2. Okay, the next one, 1 minus 2, and then 3 minus 5, which is going to be negative 1 over negative 2, which gives me a slope of 1/2. Now I know this one and this one. Those two sides right there are going to be parallel. Now down here, last one, 2 minus 1 and 1 minus 3. Goes 1 over negative 2. Now I know this one and this one are going to be parallel. So as of right now, I have two sides that are opposite and parallel to each other. That's kind of good. Now I'm going to look at the distance to figure out how long each of the sides are, to know if maybe I'm dealing with trapezoid or rhombus or what. So if I'm looking at this, remember how we said these were kind of our shortcuts? So if you want to do the shortcut for the distance formula, really you just take the two pieces of the slope that you're left with, the number on top and the number on the bottom, and square them and add them together. So this one, my distance is going to be the square root of 5. Now I can physically put that in my calculator if I want, or I can leave it as square root of 5. If anything else matches square root of 5, we'll be good to go. Okay, this one, again, the shortcut method. Oh, let me move that down a little bit. So -1. So -1 squared plus 2 squared, which gives me the square root of 5. So far I have two sides that are equal. Now to do the next one. Oops. So 1 squared over 2 squared. So that's also going to be the square root of 5. So far 3 sides that are equal. And the last one, so far 4 sides that are equal and 2 pairs of opposite sides that are parallel. So if I'm looking at this argument and making kind of my list here, so I have 2 pairs, oops, not sure what that was about. So I'm going to make a list of what I have. I have 2 pairs of opposite and parallel sides. Remember, this stuff is based on the slope. I also have 4 congruent sides, and this is based on the distance formula. So if I had to venture a guess at what this is by looking at my definitions, I would know that this has to be a rhombus. So your job is to figure out what it is based on the information. Now I will tell you, in order to solve these, I find it much easier to go through and make the table like I've done here. But the first thing you should start with is actually graphing it. So kind of keep that in mind. Okay, let's see if we can fit one more spotlight problem in here. So on this problem, I have a kite, and I also have some values. I'm actually going to plug these in here so that you can actually mark yours. So x plus 6 on this side. Over here, I have 2y plus 5. Then I have 3x minus 5. And over here, I have 2x plus 4. Now, with the way this picture is set up, this is a kite, but they're going to give us information that these two sides are equal and these two sides are equal. Our issue on the top is it's really kind of hard to solve at that, using the top one, because there are 2 different variables here. There's an x and there's a y. So if I look at the bottom down here, that's going to give me the most information that's going to kind of be helpful. So if I look at these bottom ones, those both have x's. So I can start out doing, 2x plus 4 equals 3x minus 5, and then solve from there. So I could subtract 2x. And I have 4 equals 1x minus 5. And then I could add 5 to both sides. And I basically get 1x equals 9 So x equals 9. Now our problem is when we go to solve these up here, we don't want to have two variables, but we do know that this x is worth 9. So I can actually plug that in. So if I go to do that, I can do 2y plus 5 equals 9 plus 6. So that means that 9 and 6 would be 15. I could subtract 5. So it's 2y equals 10. Then I'm going to divide by 2. And I get y equals 5. Now, be aware in this problem we are solving for x and y. In our directions up here, it just told us to find the value of the variables. So basically, you had to find x and y in this one, and that was it. So to find out that x was 9 and y was 5 would be enough. Okay?